Good evening, gentlemen, and welcome to our mid-month main meeting. Before we get started, I'm going to read the disclaimer. Please note that all our meetings are recorded and made available for the public on viewing on our YouTube channel. But by participating in the meeting, it is understood that you have accepted these terms. So, with that out of the way, um, so tonight's agenda. Um, Charlie is going to give a presentation on the Yukon Amateur Radio Association VHF UHF repeater network and its use of APRS for telemetry. And I guess Eric's going to do a poll update for the probe. And then after that, we can go through any questions or inquiries you have. And if you're ready to go, Charlie, it's all yours.
Sure. Let me just share here. Okay, where did I get? Let's try this again. Screen sharing. Entire screen. And I'm going to use this one over here. And I'm going to put this in presentation mode. Got a picture?
Yep.
Yep.
Okay. So apologies to a couple of folks who've probably seen some of these charts before. I think I used part of this package with the SOAREX group. So Peter and Drew have probably seen some of these charts. There are a few updates to it and so on, but the end part where I talk about the APRS network is probably new. I don't remember doing that one at SOAREX. So this picture at the beginning of the slide is one of the repeater sites on top of Mount Panacea. This is a site that's shared by the radio club as well as the railroad that runs from Skagway up to Carcross and also Transport Canada. So three different groups have equipment in this particular comm shell, and whoever is making a trip up there to save helicopter time will work on all three pieces of equipment. So that's part of the secret for the group is they've got so many repeaters and so on simply because they've got lots of great partnerships, and I'll talk about that a little bit too. The club was founded in '75, has about 35 members. And of course, the most valuable asset it has is this large repeater network built over 25 years, actually. And in fact, there's supposed to be another node added this summer if it comes to pass and the wildfire season isn't too crazy. The group did a number of things. The last time, I guess about 3 or 4 years ago, they did a strategic planning session. Do this every kind of 3 to 5 years, and the idea of that is to understand, what the group is interested in doing and what they think the areas of key focus should be. So, for instance, emergency communications is very high on the list. Supporting the community, including communications from various events, like there's a bike race and a foot race, through territory that has no cell coverage. So the repeater network, having folks at checkpoints with radios and so on, is kind of important if someone gets in trouble. They've also been pushing to increase some youth interest and trying to involve whether it be scouts or high schools or so on, and then for the members and even guests, provide some learning opportunities with group workshops and building projects together, encouraging and supporting homebrew products. And the other one, which is kind of interesting, and SOAREX does this a little bit, is to use champions to start and maintain kind of larger projects. So if someone is passionate about, for instance, in the case of the probe, Peter was passionate about it, and he's been kind of driving things to happen. And that's what happens up there. If somebody's got a bee in their bonnet about particular technology or whatever, the group will support them, but they champion it, make sure that meetings are called and those sorts of things happen. And the other thing they did was change their monthly meeting from an hour of business, which was very boring to attend, to a half hour of business and a half hour presentation of interest of some kind, kind of like what we do here. And finally, they wanted to increase HF activity because with the network, there's a lot of focus on VHF stuff, and so just starting to do some stuff with HF was kind of important. Excuse me just a sec. I'm just going to turn off radio here. So here's a look at the repeater network. There are 21 mountaintop sites, another 5 or 6 sites that are not on mountaintops that are accessible. For instance, there are 3 local repeaters in the Whitehorse area. There's one on Watson Lake, one in Dawson, one out at Haines Junction. So they aren't linked to the network. They're for kind of local use and experimenting. But the main network, VHF, all the drops are VHF, and they're all linked by UHF, and it's always fully connected. So if I key up a microphone, 48 transmitters key up across the territory and down in through northern BC and actually all the way down to Juneau, Alaska. So it's quite a wide network. They try to make sure it's up and running by doing a nightly check-in on it, except in the winter, of course, when trying to preserve batteries in case there's an emergency that crops up and people actually need to use it. The coverage from the mountaintops is amazing. The transmitters we use are typically 5 watts. There are a couple of 30-watt transmitters, but generally they're 5 watts, and you get 100 to 200 kilometers on those 5 watts from being up so high. This particular one in this picture is Atlan Mountain, just outside Atlan, BC. And a friend of mine was up there in a helicopter yesterday, sent out a message this morning that when they jumped out of the helicopter, it sank in the snow up to his waist. There's still a ton of snow up there this time of year. They had to dig for a couple of hours to actually get the calm shell open so they could do maintenance on the gear. Most of the sites are in fact helicopter access, and that's where the partnerships come in handy, because if you've got multiple groups sharing the cost of a helicopter, it's not quite so painful. I have a few slides here on some of the other different sites. Hayes Peak is one near Teslin in the Yukon. Mount Nikolai is it's not that far from Mount Logan, actually. It's on that side of the territory, that side of the highway that runs to Haines. Interesting thing you can see on this is, again, this is partner shared stuff. Everything's solar powered. This is a UHF drop, which in this particular case Parks Canada has put in place, and then the VHF drop that's ours. And we share that VHF with, no we don't, sorry, not this one. This Yagi is Parks link to another repeater site, and this top hat is our link to another site. This particular one's a metal box, sort of like a sea can. But a lot of places, the club was able to pick up these old calm shells, which were essentially donated when they Transport Canada shut down part of their network. They had these things and they had to move them out anyway, so they gave them to the club, which is kind of nice because they're about $110,000 to buy a new one, so that ain't happening. By the way, we talked at one point about lithium iron phosphate batteries in repeaters. These are the old lead acid ones that are coming in here, slung in by the helicopter. There are 1, 2, 3, 4, 5 bays there. Each bay is about 300 pounds. So there's 1,500 pounds that has to be manhandled into the com shell and bolted down and connected up. It's it's a slugfest at times. A couple other shots of interesting places. Chili Ridge is up above Skagway, and this is a site that's shared with the railroad that runs between Skagway and Carcross these days. It's a tourist train that drives them up through the mountains, and they use this for for communications with the train, controlling, and so on. This one, Decola, is a very busy site. You can see the number of cavities that are down here, these are all the VHF ones. These ones are, well, these are VHF as well, but these are all UHF up here. A lot of cavities, a lot of tuning, a lot of opportunity for interference, and we have one guy who's just a master at tuning these things. He'll go in there with a spectrum analyzer, spend 10-15 minutes and line everything up, and everything will be perfect. Me, I can do it, but it's going to take me most of a day, and and even then, might be a second day after that. Mount Panacea. This is one that's getting a visit this week. This is one that I have an APRS unit installed of the type I'll talk about later. Cluckshoe Mountain is an interesting one to talk about because when the guys, it was installed about 10 years ago, and when someone flew by in a small plane this spring, it was missing, just completely disappeared. I guess there was enough high-speed winds and so on. Possibly one of the cables that hold it up snapped, but it's gone. It just blew off the mountain. And so there's an effort to try and get it replaced this summer. Problem is with so many repeaters, and these things need maintenance pretty regularly, and the cost of helicopter time. It may have to wait a few years before it gets put back into the network. It's just a fact of financial life. The club is very much like most clubs. There's about 35 people who are regular members, probably half of that are regularly involved in everything going on. They've had a number of new, younger members in the last 6 months, which is quite nice. And that really came from them running local courses. But the folks that are part of the club are everything from mechanics and welders to health professionals, engineers, lawyers, pilots, the same kind of mix that we usually find in ham clubs. This little inset picture here is the antennas on what's called Haco Hill. Not much of a mountain, but considerably higher than the other surrounding terrain, just outside Whitehorse. And this is one you can drive to in the summertime, snowmobile to in the winter. And again, here there's Transport Canada, there's Wildland Fire, there's us, of course. Even the weather channel that broadcasts on the sort of 450 megahertz band is there, and a few others. This is very busy, occupied site, and it's apart from the link into the wide area network from here, one of the local repeaters that is not tied into the network is also located in this building. So lots of gear here, and spent lots of time chasing interference there, and it's still not completely solved. There are folks working on it all the time, trying to get things working properly. Groups involved in community events. By the way, this presentation has a lot of stuff about the club, and that's because it was originally put together to, tell people what the club was about. And I'm just kind of stealing from it because I didn't put together all these pretty charts. My buddy Scott did. Put together most of them, at least. So community events, the Klondike Road Relay I talked about, which is a foot race, the Kalani Chilkat International Bike Race. Jamboree on the Air with the Scouts is most years. There's a good turnout for that. In 2007 was the Canada Winter Games, and that's coming up again in a couple of years. In 2012, the Arctic Winter Games, and then the military and government do some disaster planning scenarios in each of the territories. It kind of rotates around. June 2019 was Operation Nanook, which required us to actually design and build some new equipment in order to collect telemetry information from an air quality measuring gear that was kind of dropped down where wildland fire, where fires were taking place. So I wanted to make sure that there were terrible health hazards for the guys who were in fighting the fire. And of course, these things are dropped in places where there's no power, no communications. And so we were given the challenge to figure out how do we get that data back to actually a database in Ottawa. It was a lot of fun. I guess the APRS equivalent, the emergency communication stuff, the biggest one for them was in 2012, the main telephone switch, which not only does all the local telephone, but all the internet, all the transport of other communities go through that hub, links to satellite, links to fiber, all go through that switch, and it went down. So there was nothing, no cell service, no phone service, no internet. The place was completely quiet. So that was a pretty big outage, and the club played a big part in. One person went to the hospital and relayed messages. One went to the emergency services and relayed messages. One went to the RCMP, and various other key locations to share information around. Was quite a challenge. And also they get involved in search and rescue quite a bit. A lot of members of the Hand Club are also members of the local search and rescue organization. These are some pics that I like because these are some kids I was working with in Scouts. Here's a group of first-year Scouts. They're talking on HF to Scouts in California, actually, and exchanging ideas. What did you have for breakfast, and how cold is it there? Those sorts of things. This one up in the opposite corner was the older guys, the 14 to 17-year-olds, the venturers. We did a tape measure Yagi building exercise, and then we did fox hunts using them. So that was kind of a fun way to spend the weekend. Down here, this is one of the sort of buildathons that were going on, and you can see there's a couple of scouts in here, even scout leaders who attended. We were building pixies, and we have one member who was a former teacher, very good at it. He broke it down. It's a relatively simple circuit, but over 3 or 4 nights, we went through each section of the pixie, what it's doing, what the component values are, what they are, and then we actually built it and measured it. So it's a lot of fun. And this is just a digital setup at one of the Jonah camps. So besides the repeater network, there's D-Star, Echolink, IRLP, All-Star, both analog and digital gear up there. So we can get out over the internet if necessary. Can do check-ins from basically around the country. This is Hakel Hill. We had an issue, took snowmobiles up to repair it, but you can see the antennas, how much ice is actually built up on these. And here Scott's adjusting one of the repeaters. All of the repeaters pretty much are Daniel's gear, and pretty much all MT2, a little bit MT3, and it's well known for its very low power consumption. So sitting on receive only, it might be 25 milliamps for the repeater. Which, if you've got 12 kilowatt hours of battery backup or more, it's going to last a long time, and it can make it through the winter when you're not getting any power from the solar panels. I mentioned partnerships earlier. I won't go through all of these, but you can see there's a large number of groups who we work cooperatively with, and includes government bodies like Environment Canada and parks and fisheries. We even had a marine radio network set up for a while. That's been mostly discontinued. There's just one repeater now for marine in Atlin, BC, because it's quite a large and very popular lake. And a couple of years ago, we decided that we wanted a communications trailer. So this is the outside of the trailer, and this is the inside of the trailer. We did a request for government funding and received it, and so a good chunk of the cost of this was borne by a government grant, and then all of the labor to put it together and outfit it, including rebuilding it, insulating it, powering it, all those good things, were done by volunteers in the club. And this is kind of what their field day looks like. You'll see here, there's this is one of the construction floodlights, I guess you'd call it. It's a diesel generator with a crank-up tower, and has lights on top of it. They can be turned on or off. But we use the crank-up tower with a little mast on top of it for HF antennas at field day and on other occasions. Someone asked me once, does the club use wind, and why is everything solar? Well, here's why wind is not a good idea. It just freezes up like this very quickly with this rime ice, and it just it won't spin until close to July. Also, while there was a lot of it deployed in the initial part of the network, it failed quite quickly. It's a mechanical thing, spinning 724 all year. There seems to be always a breeze up on top of the hills. So this is the last surviving one. It's on Pilot Mountain, which is I don't know, maybe 10-20 kilometers outside Whitehorse, and it's the last one that's still operating. But Pilot also has solar panels as well. And here's Atlin, that one that I showed you earlier, when it's covered in rime ice. That's the one where the guys went yesterday and sank up to their waist in snow when they got out of the helicopter. This is another picture of rime ice, just to kind of let you know what the environment is like. This is a microwave tower from one of Northwest Tel's towers. This little dot you see down here is actually a snowcat, which is quite a large vehicle if you've never seen one. And that was the only way you could get in there in the wintertime, was by snowcat or by helicopter. So if you had to take a pile of tools and things or additional equipment, or even a bunch of people, the snowcat was really a much more cost-effective way to do it. This stuff was over 10 inches thick, and they had to take it off with hammers, basically, just knocking it off so that the microwave system would start working again. So let's talk about APRS. That's the next thing that's going on here. So each of these sites in the network were attempting to equip with an APRS unit that, of course, are all linked. And they're linked by UHF 144.39. They're useful for people who are driving and using APRS for messaging or for position detection. That's a fairly popular thing up north, but also for telemetry. So, with this unit, I can measure various voltages. I can measure temperatures in the comm shell, outside the comm shell, in the battery bank, whatever makes sense. And a number of voltages if we've got 2 or 3 battery strings for different pieces of equipment. Some of the partners want to use their own batteries. We can remotely monitor that as well, so that we know if their batteries are in trouble. At least give them a heads up before they fly up to find they've got, a battery problem. At least they know if the battery voltage is really low. Well, it's solar panels and charge controllers and possibly batteries. So at least take a solar panel and charge controller with you, because those are easy and light. This is a box that I've put together for the purpose of collecting telemetry data. It will be, have written on it in pen when it gets deployed, the call sign for the particular repeater it's going to, the location of that repeater, GPS coordinates. And if you turn up at a site and want to manage it, it puts up, if the Raspberry Pi is the basis of this box, it'll set up a hotspot so you can use a phone or a laptop to talk to it, reconfigure it, do what you need to do. And to log into it, it'll just put the user ID and password on it. Again, that's for the plugging into the actual Pi once you are part of the hotspot and get your IP address from it. Inside that box is there's a Raspberry Pi Zero in this case, although it's since been updated to 02W. There's a outboard A to D converter, a 16-bit A to D converter, and so it communicates by I2C over to the Raspberry Pi. There's also, you can see here, there's this is a sound card, a cheap USB sound card, basically, with the cover removed from it to make it easier to mount. And then, power comes in here, radio connects over here, and one-wire temperature probes up to 3 in parallel can be put on here, and the Pi will, be able to distinguish between them since they have a unique code. If we take the Pi and the sound card off, this is the board underneath. This is actually my test board, so it's got lots of sockets on it, which normally I just solder things in. But it has a couple of power FETs on it. These are like 60 milliohms, and will do up to 60 volts, so they're quite robust devices. We can use these to shut down partner equipment. So if we run the partner power through this unit, I can send an APRS message to turn off the power. So for instance, Parks Canada doesn't use their network in the wintertime. It sits there consuming, those few watts that we can suck out of the solar panel. If we could power it down remotely, that would make life a lot easier, batteries smaller, the whole 9 yards. So this has this capability. We haven't actually used it yet. There's lots of worry about, well, gee, what happens if you power it down and it doesn't come back up again? If that happens, this is some digital timer circuitry over here, and you send a message, an APRS message to the Pi. Within 2 weeks, it will reset the internal counter. So sometime within a 2-week window, you need to send basically a refresh message to it. If 2 weeks expires and it hasn't received a message, which is possible, antennas blow over and things like that, then essentially it turns the partner equipment on its own. The other one is used actually to power cycle the Pi. So there's also another timer that's about an hour long. So if it doesn't get reset within an hour, it will reboot the Pi by removing the power from it. I'll show you the schematics in a sec. This little beastie in here, this is a 12 volt to 5 volt 3 amp regulator. And we've been looking at these, for instance, and similar ones for use in the backplane radio. There is a ton of ripple comes off of this. So I've got a big fat capacitor here, which basically gets rid of it. But in truth, the 5 volts isn't really much in the audio system. It's really for the Pi, which internally regulates that down to 3 volts. So it's not a terrible problem, but we really don't need the extra noise. So that's why I added it on. A quick look at the circuit. Just very quickly, this is the Raspberry Pi here. This is the I2C interface with the level shifters, because the A to D converters are running off 5 volts, but the Pi is a 3 volt device. Its inputs and outputs can only be 3.3 volts. This is the power regulator that we saw before, with a very small decoupling cap close to it, and then a fat one across the board. And it gets turned on or off from a timer. I'll show you on the other page. This is powering on and off partner equipment, and there's an LED which indicates that the partner equipment is on or off. Some of these other ones are just voltage sensors, and this is the interface to the radio. The little circuit boards I think I've shown before, with a radio interface. They come. Pi talks to the sound card. Sound card talks out through this connector to microphone, speaker, PTT, ground, those kinds of signals. Second page of the schematic is really the timers. There's a 32-bit counter here, driven by a 555. I chose a 555 rather than trying to take the clock off of something like the Pi, because dividing it down to try and get to 2 weeks is crazy. So I've got this set running at about 50-60 hertz, which eventually, when it counts down the 2 weeks, it will flip a bit into the Pi. It also does an output to the Pi after 1 week, just so it can send a reminder message in the software. And this is I call it the watchdog. Basically, what it does is it's the one that turns off the Pi if the Pi hasn't got around to it for a while. We assume the software has gone insane, and so we'll give it a kick in the pants to get it going again. We use lots of different HTs for APRS. We have some old Motorola MT1000s, and we got a box of them donated to us, actually, from one of the government agencies that no longer needed it. So we adapted them to work on the frequencies that we need, reprogrammed them. And in this particular case, we need to physically wire stuff up to the connector, because these had a block that slid over the top and connected pins to all of these things, which we don't have many of. We might have 1 or 2. So with the wires on the MT1000 soldered on, it loops back. This is the box with the APRS unit in it. This is power in and out. And this, a coaxial antenna can be connected here, and that goes to the cavity filter string that allows us to inject APRS signals on the same antenna as our UHF links between transmitters. And so that's the whole thing in terms of a picture. You can see the radio underneath and the APRS unit on top. This thing off to the side over here is a temperature probe. This one was only configured for 1 probe. Like I said, there can be up to 3. And this green wire is for sampling of voltage at a different location. We tend to run this system on 9 volts instead of the original 12 volt design. The Daniels gear puts out a 9 volt reference, which we can take a couple of amps out of, no issue. And when the Daniels voltage drops low enough, it shuts down so it doesn't destroy the batteries. And so when it shuts down, the 9 volts shuts down, and so consequently the APRS unit goes away too until the spring. I think that's it. Other than I would like to show you, just before I wrap up here, the data that the APRS units send back. Bring this over here. Gets sent over the APRS network. It ends up at APRS.fi. And so I've got a little program basically that scrapes APRS.fi and searches for the call signs of the various repeaters that have APRS monitoring on them, and then puts it in the spreadsheet so you can navigate to this page at any time and see the status of the network. And what you'll see is there are a few here that are older equipment that don't have temperature and voltage. We're trying to upgrade those. Some certainly do. I think this one is actually one of the ones I just showed you. But some of them, here, Dawson, for instance, we got one RMD, hasn't reported in since 2023. So it's on the list for repairs. There's one above it, hasn't reported in since 2021. We know that at least the APRS unit needs to be replaced in those places. So when there's a trip planned to go in there for whatever reason, they'll pack one of these APRS units along and deploy it at that location, so that spot will get added to the network. And of course, once that happens, then I get some messages, and then I'll add that to the list here of places that are being reported. I think that's it. Do we have questions?
Go ahead, Pete.
Thanks, Charlie. Most interesting. I've got a few questions here, so I'll read off a couple. But how are those comm shells mounted to the ground? Is there something other than those cables? Are they bolted to the rock as well?
Yeah, typically there's there's multiple ways to do it, but there'll be a wood floor inside the fiberglass on the bottom of it, and then there'll be metal plates with lag bolts going through and rock drilled into the rock. In other cases where there isn't good solid rock to link it in, then they actually put a ring in the ground, and then fill it with rock so the ring is solidly buried, basically, and then bolt the comm shell to that. And
the comm shell that was lost at was it Cluckshoe?
Yep.
First off, did they find it? Do you know how that one was bolted down or mounted down?
Yeah, we actually saw a picture of that one, right? So it was bolted down into the rock, and it had guy wires, but perhaps the guy wires were tensioned too tight, and so when they got there's lots of vibration when wind is blowing. Like I've been in those comm shells when it gets windy, and it's noisy and vibrates like crazy.
Will they make an effort to locate it, or they'll just write it off?
They make an effort to locate it, but in fact they did. That one's shared with I think it's Parks Canada shares in that site. So they send up a helicopter, but it's spread down the mountain. There's pieces everywhere. The comm shell's not recoverable, and neither is the gear. It's all destroyed.
Okay, I got more, but I'll come back to them.
Dave.
Excellent presentation, Charlie. Very, very interesting. I love the scenery you've got. I envy you being able to go out to those locations, be on top of a mountaintop. Did you? I got a couple of quick questions. Like typically, how long were you out in the mountaintop? Did you ever camp up there, or were you just up there for hours? And in and out, or did you ever stay at
It's
the top?
it depends on what work has to be done. Sometimes it's a couple of hours. Sometimes it's the better part of a day. Personally, I haven't had to stay up there, but my buddy Jeff has told me about spending a night in the calm shell because the weather moved in and the helicopters couldn't fly. And you know, if the helicopter can't fly, your choices are settle down for the night or try to hike out. Which, if there's a storm going on, you don't want to do that.
Yeah, I was just curious to know if you had any special tents or any special equipment for
No,
like
no.
emergency.
Jeff always packs a couple of sandwiches, extra bottled water, and a lightweight sleeping bag in there.
Okay. The other question I had, the last question, I could ask you a ton of questions, but that piece of APRS monitoring equipment, how did you go about testing that? Because it seems to be, it's got the whole thing is predicated on failure, right? To avoid failures. So I'm just kind of curious to know how you went about testing various failure modes in it to make sure it was robust enough that it would always, it would always fail in a positive way.
Hmm. Yeah, good question. So the first prototypes sat out. I was still in the Yukon when the first prototypes, and they sat out in my camper in the backyard over the course of the winter, reporting APRS data. Um, and then you have to send it a keep alive message every couple of weeks. So if you don't do that, um, it automatically fail safe turns back on the partner equipment. So just go look at the LED and see if it's on or off after a couple of weeks. The other one I had a fair amount of trouble with, the one that resets the Pi, and I'm still not happy with it. I've disconnected that part of the circuit for the units that I deployed so far, just because I was in a big hurry. I didn't have time to solve it, but it didn't seem to recover. It would power off the Pi, which should reset the timer automatically, which then turns the Pi back on again. And for some reason, the Pi seemed to stay off. I'm confused why that would be so. Scope tells me everything's working great, but yeah, there's 6 units that don't have that feature. Sorry, Dave, you're muted.
Yeah, at first I thought, oh, why aren't you using the watchdog timer in the Pi? But then that's the failure. In case that fails, you want to have an ultimate hard reset to say, okay, I'm going to hard reset everything. So that's why you need that external
Right.
watchdog timer. And did you give some thought about putting in a small little pick, like a 6-pin pick or something like that, which all it does is just do a watchdog timer and resets a pin?
Well, it's funny you should mention that because my latest version of this thing, which I just got boards back a couple of weeks ago from GLC PCB, I'm using a Raspberry Pi Pico to do all of the A to B stuff, the temperature measurement stuff, the timers, all of that is in the Pico. And it's a fairly significant cost reduction by doing that. Although, to be honest, my buddy Ed, he's not here this week, but he was here a couple of weeks ago. I invited him to attend some of the meetings. He has come up with an entire APRS unit based on the Pico. It does the sound card function, the A to D converter functions, all of that stuff on the Pico. So you couldn't run the high level software that I've been using for stuff, but the Pico has 2 processors in it as well. So you can have one that's just doing the Coke and Ice stuff, and the other one that is doing some of the more logic functions.
But still a single point of failure. I think the board you've got is really clever because you've got the whole design is predicated on a single point of failure to always try and recover itself. By putting all your eggs in one basket, in one microcontroller, that, if it fails, you're pooched. And I get it. This thing's on a mountaintop, and you want to make sure that when it fails in a desirable state. But
Yeah,
the last part,
generally it's about $15,000 to $20,000 to take a helicopter up there. So you don't want to do that
right?
very often.
Exactly.
It's not pay for it very often.
So, my last comment: if ever you need someone to carry a tool bag, let me know. I'll do it. I'll bite the hole. It's okay.
I'll keep you in mind, Dave.
I think Eric was next.
We'll all chip in for the one-way ticket. Don't worry, Dave. It's all good. Yeah, no, great presentation. I feel like I've been there now. You've done this, the visuals from it a few times. I myself, that would be a trip of a lifetime to, be up there and see some of these installations. So, but I'm curious about the power more than anything else. That seems to be an interesting thing to have solved, that everything stays up. I mean, obviously solar does everything, right? Like there's
Except
no
in the winter.
backup generators or anything of that sort.
No, just
Nothing.
solar. Solar
Just
and
solar.
big batteries.
And what's
And low power consumption.
Yeah, like everything is low voltage, I presume, right?
It's all the gear is 12 volt, and like I say, in receive mode, if it's not transmitting, it draws about 25 milliamps
Right.
per repeater shelf, which would be the UHF and VHF link, for instance.
Right. Okay. I guess I'm just too naive about that equipment. It looks like the type of thing that would have a much higher requirement for current, but
the newer versions do, in fact. It's a great story how the club got that equipment. They offered to do some testing for Daniels, the manufacturer, on mountaintops, severe environment, minus 50 temperatures, that kind of stuff. And Daniels was very happy with it. And then when the universe moved from wide FM to narrow FM for pretty much all the commercial stuff, Daniels needed a new design. So they called and said, "We have some leftover gear. Would you like to have it?" Everyone was, "Of course, we'd love to have it." And a 40-foot trailer turned up, packed half full of Daniels gear. So there's enough there to last another 50 years probably.
Right. Okay. Any idea what the total wattage for all the panels is per comm shell?
It depends on the site. Some sites have multiple partners, and there's multiple radios per partner. For instance, some sites it's just us. It really depends on what gear is in there.
Right.
But generally, you can see in the pictures, we've plastered solar panels on the outside of the comm shells pretty much everywhere.
And that's how it stays snow-free as well, because they're more or less vertical, right?
Yeah. And when we're trying to get that extra power, because they're close to vertical, the sun barely makes it over the horizon, which is fine. At least you've got a direct line at that time of year. And in the summertime, it's not direct, but guess what? The sun is up pretty much 24 hours a day, so you're getting a lot of energy from the panels.
Okay, very good. All right, thanks.
Drew.
Yeah, thanks. I love this presentation, Charlie. I've never seen this much of it. I've seen little bits and pieces, but this kind of put the whole thing together. First thing that occurred to me was that you're really just building satellite grade stuff. It's kind of the same situation. Once it's there, you can't go and get it. So that's fascinating. With your APRS, and I am assuming that you're coding the whole thing. Like you're not using anything. You built the whole thing. How much on a line in terms of telemetry can you send? How many different points? Assuming, say, four digits or 3 digits per. Is there a limit?
So APRS packets have defined telemetry fields that you can use. I don't use them. I just pack all the information into a text file, and the text file gets copied into what gets sent. And I believe the limit in the comment field is like 72 characters.
That's what I was wondering, if it was the same as an old Fortran card. I know the Bionics used to have a compression system that they would send out a compressed, like the Mike E style
Yes.
compression. I was wondering if you were using that as part of your system.
No, I don't need the extra data space, and
Right.
And Mikey is hard.
Yeah. No, I wasn't sure. I mean, you've developed a lot of this stuff pretty much from the ground, so I wasn't sure how far you'd taken it. I'd be intrigued to see how you do the Pico trick. I mean, if you're running all of this stuff through one Pico, this man is really accomplished something.
He certainly has. Maybe we'll get him to talk about it at one of our meetings.
Well, anyways, that was wonderful, and I envy you doing this work, but thanks.
Kevin.
Yeah, Charlie, that was great. I just a couple of comments or questions or whatever, but so those Raspberry Pis run on SD cards, and SD cards can be known to fail, catastrophically with no warning. Have you had any issues? And a lot of that equipment is like, I'm assuming commercial grade. So when this stuff is running at minus, a lot, like minus 40 or whatever the temperatures get to, have you had any issues with that kind of stuff failing?
I have not, but I'm aware of the concern. But so far, it's been okay.
Okay. Well, that just speaks volumes about how reliable this stuff really is, even though the specs are not quite so confident.
Yeah, the one problem that does crop up occasionally is that the I2C bus gets some errors, and sometimes I won't be able to read weather telemetry or something of that nature. So that has happened on a couple of occasions. Mostly so far, with crossed fingers, it's been actually in the club trailer, because we have the unit in there, so that if the trailer should suddenly decide to leave the territory without us knowing, we know where it is.
That's interesting. Okay. Well, anyway, thanks. No, that was great.
Peter.
Charlie, does the temperature extremes like summer to the dead of winter, does it have any effect on detuning the cavities?
No.
Okay.
I don't know why, but they seem to stay aligned.
It just seems like, I haven't got much experience tuning cavities, but I do remember doing some for the club repeater many, many years ago, and it was kind of finicky, and it got me to think about, the expansion of the metals and all that kind of stuff, and would it do anything for the detuning?
Even worse than that, all of the equipment is donated from sites that like Northwest Tel turned down their VHF network for employees. They went to a P25 system. So the cavities that they took out, they gave to us. So they're used. Some are corroded. Some we had to junk. But
yeah, can't complain though. What is the temperature extremes that you've seen in some of these comm shells?
I've seen a minus 43, I think, and on the plus side, up about 45.
Well, you think that minus 43 would play a little bit havoc on those batteries? Oh, you're muted, Charlie.
You're muted.
Sorry. They're commercial grade batteries for sure. A battery plant for one of these sites runs maybe $10,000-$15,000 in lead acid. So we're busily at this point converting everything to lithium iron phosphate. which actually is quite a bit cheaper. And as long as you get the ones with the heaters, they're fine in the winter.
Okay, thank you, Charlie.
Hey, Peter, Winnipeg's not looking so bad now, eh? Anybody else? Oh, Charlie, that was great. What an experience. I'd jump on a travel with Dave and get the heck up there. Uh, I grew up with -60 in Winnipeg, so temperatures wouldn't really bother me. I know how to dress.
Yeah.
But that was fantastic. I guess you did this over a number of years, or is it like a 2-year stint, or?
You mean deploying the APRS stuff?
Yeah, well, your involvement in it.
I've been involved in it since, I guess, 2018-ish. Some of the early, and there was an APRS network of sorts when I started digging into it. Some bionic stuff, which failed regularly. Some Argent data stuff, which some failed and some didn't. I started working with the guys there to try and understand the failure mechanisms, but before I retrieved a failed node, they seem to have gone out of business because their web page is gone.
Oh, fantastic! That was great. Do it again sometime when you get an update.
Yeah, for sure.
All right. Anybody else have anything for Charlie? I guess that's it. Thanks again, Charlie.
You're welcome.
I think not Peter. Eric had the probe poll update or something.
Yes. So there was a poll that was put out, I think a couple days ago, perhaps 2 or 3 days ago. Anyway, for the RF probe that we've been working on, one of the two side projects, I guess we'll call them, including the backplane radios. So put out a survey just to see what interest there was for acquiring a kit, purchasing a kit, I suppose, as well as interest, as we talked about, I think in the last meeting or two, about whether you were interested in participating in a buildathon for the kit, and if you'd be interested in a manual for it. So 11 responses came in to the poll from the group, and it was overwhelmingly positive, I would say, in all respects. All 11 are definitely interested in acquiring a kit, which, is obvious since they answered the survey. But as far as buildathon, pretty much, that would be 10 out of the 11 were interested in an in-person, centrally located spot. So only one respondent was a virtual participant, so could be for reasons of distance. And as I think we mentioned at the last meeting, we do have the option. I think we have enough technological chops to be able to pipe somebody in via Jitsi or anybody else that would like to participate. So I think that is totally doable to do a hybrid. But looks like the majority definitely wants to do it in person. So, and as well, just about everybody, I think maybe 9 of the 11 respondents are interested in a manual, which I believe Peter is already tentatively making some steps towards, as far as a build manual, and with some operating tips in it, I would think as well. So anyway, so that was the gist of the survey. I think we're mostly in favor of all of the above, we'll say. So, so that's good.
I think Michael had a comment.
Michael, yes.
I have a question. If firstly, is the case is done, right? So there's going to be no changes to the case. And the reason I ask is I would like to get my grandson to make a couple, if that's
Right.
possible at this stage.
This, presuming there's no more changes to the physical form factor of the case, then yes, the case is completed, and I've already thrown my hat in the ring as far as anybody who wants a case printed. I'm more than happy to do that for them. But the files will be available for printing if you do wish to do it on your own or have somebody that you know that has the printer to do it. So that's not a problem.
So you have the files.
I have the most recent files as of our Smiths Falls trip.
Okay.
If there's been any updates, then those can be made available as well. But yeah, they're readily available at this point. So
Okay, thanks, Eric.
Yep. The only thing we don't have, at least at the time of putting the questionnaire out, is a rough cost estimate for the kit. I don't know, perhaps Peter, can you speak to that at all, as far as, or Dave for that matter?
Not really. I did as a thought exercise a few weeks ago, started to go through my mind on it, but I can't remember where I ended up. But no, I'm not sure. I don't think it's going to be that bad.
Right.
No, I
board
better not.
cost was
Pardon me?
nominal.
Well, the board cost is only a couple of bucks, and you figure it's majority of it's what, caps and resistors, so that's pennies. Two active components in it. I mean, the SMA connectors are probably more money than the active components.
Right. Yep.
So, go from there.
Yeah. So I would say probably conservatively $10, under $10, something like that, or 10, 15 maybe. I don't know. Don't hold us to that. But that part will be edited out of the final recording. So
yep. And the case would be at an extra cost, right?
Yeah, but again, nominal. I mean, we're talking, 25 cents worth of plastic or something. It's not much. So
yeah, okay. I have no idea. I don't know what's involved.
Yep.
But I would definitely want one.
Okay. All right. So that was it as far as the RF probe survey went. So back to you.
What's going on with the backplane radio? Anybody?
Oh, work in progress. We had a meeting last night, getting caught up. Work is well underway, getting close to completion, I guess, on the backplane itself. Power supply board's coming along, and a little bit of a redesign on the daughter card. Nothing too heavy. It has to happen, and of course now with the Pro project starting to wind down somewhat, have more time available for the backplane. So I expect to, at least from my perspective, my end of things, I'll be able to concentrate a little bit more time on it. So I suspect, of course, being the summertime too, it's a little more tougher to get in the shack, but it's slow progress, but it is coming along fine, and I expect it to move on a little bit quicker going forward.
Yeah, cool.
Provided we all remember to show up.
Sorry, go ahead.
Provided we all remember to show up at the meetings.
Yeah. No, I was just interested on the progress. Okay. Eric, I see you posted something about field day. I didn't get a chance to read the whole thing.
Yeah, I put up a poll, I guess that was just earlier today, right? About the field day, which is coming up soon, right? Starts a week from Saturday. So, yeah, I just wanted to gauge interest really on who is interested in getting together for that. So, currently I've got for responses. I mean, again, it's only been up for less than a day, so I'm not expecting everybody to have gotten around to it yet. But that means, I guess, including your host, 5 of us will be. You know what? I didn't see if the response was in the positive. Oh, no, sorry. Uh, 3 responded positively. 1 was a maybe. So 4 or 5 people so far. So anyway, so yeah, it's certainly more than welcome to come by the farm. Those of you that have been here before know that it's a good event, and you know, it's a nice opportunity to you know, try out maybe a piece of equipment. Let's say you recently acquired an Elecraft K2, and you know, you haven't actually put it on the air yet. Well, there's an opportunity to do that. So those of you that want to see first, you know, first light, as they say in the astronomy circles, might be able to do that, or you know, bring up something you've been experimenting with, or want to test out or try out that you just haven't gotten around to. So it's a nice way to do that. So anyway, staying over is an option as well. You know, so that is open to anybody that wants to stay over. Definitely the Saturday night. That's the main event, so to speak. If you're not feeling like heading back home, then you know, by all means, we have the space. And if you want to stay outside, then we have pretty much unlimited space. So kind of on a first come, first serve basis, I suppose. So anyway, yeah, I'll leave the poll open, obviously, for a while, and we'll see what other interest there is. But you know, in a few days, maybe by Sunday or whatever, I'll send out more specific information to those that expressed an interest, and we'll go from there. So, pretty straightforward.
Yeah, yeah.
Yep.
Well, unfortunately, Bonnie's booked that weekend for Quebec, so
No.
I won't be able to attend this year.
Okay. Well,
It's a memorial for her mother and father.
okay.
So,
do you have a radio that you could pack with you though, or?
If I bring a radio, I'll be staying home then. No, unfortunately, no.
Yeah, fair enough. Fair enough. Yep. Okay. Well, that's a priority. So.
And there's
Okay.
lots of room in the chicken coop.
Right. Yes, indeed. Yep. Nesting boxes are prepped and ready. So.
Yeah, or you can sleep with Donkey.
Right. Yes. So many options. So many options. Sleep with a donkey. Sleep with a chicken. Sleep with me. Whatever you want.
And you're
choose your animal.
You're not cheap. Cool. It's too bad. I've enjoyed every one I've attended.
Yeah. Okay. Well, it won't be the last. So.
Yeah, I know.
Yep.
Okay. I guess we've basically come to the end of our agenda. Does anybody want to bring up any kind of topic or have any questions or anything at all? No, it doesn't look like it. Go ahead, Pete.
I'm just going to say we're running low on presentations, so if somebody's got something in their back pocket to do, we're looking for some. That's it for me.
Okay. Well, gentlemen, should we just call it a night?
Sounds good.
All right. Okay, gentlemen, have a good night. Have a good weekend. And the mixer is on the 2nd of July. So that's the Tuesday? Yeah.
The Wednesday. Yep.
Or Wednesday.
Yeah.
Thanks for running this at all, Ken. And thank you, Charlie, for a really interesting presentation.
Yep. Absolutely.
Yes. Thank you.
Okay. Have a good night, everybody.
Good night.
73 to
Night,
1.
all.
Good night.
Thanks. Night.